Hey, calculus, chance to get back to the chain rule here. We're going to go over some a little bit more challenging examples. Let's look at the chain rule itself. It says that if you want to take f of u of x and take the derivative of it, it's equal to f prime of u. So the derivative of the outside with the inside left alone. I'll raise that just in case you prefer it that way. Times u prime of x, the derivative of the inside. And so as we write this one out here, we make our little boxes. We put u of x here, and we put f of u here, and we get f of u is u to the fourth, and the inside is 2x minus 3. The derivative of the inside is 2. The derivative of the outside, 4u cubed. Multiply those together, we get f prime of x is 8 times 2x minus 3 quantity cubed. Next one, same piece. We have the inside is x minus x squared. The outside is 6u to the fifth. Take the derivative, we get 1 minus 2x. The derivative of 6u to the fifth is 30u to the fourth. Multiply those, now we get 30 minus 60x times u, which is x minus x squared to the fourth power. Do you remember your trig derivatives? My trig derivatives, I have the outside, which is negative 4 secant of u, and I have 5x squared. Derivative of 5x squared is 10x, and the derivative of negative 4 secant of u is negative 4 secant of u tangent of u. Multiply, we get negative 40x times the secant of 5x squared times the tangent of 5x squared. This one would be more helpful, instead of using the quotient rule, to just rewrite it as negative 5 times x plus 5 to the negative 7th power, and then use the chain rule. And so we have negative 5u to the negative 7th, and we have x plus 5. The derivative of x plus 5 is 1. The derivative of negative 5u to the negative 7th is 35u to the negative 8th, or 35 over x plus 5 raised to the 8th power. So those should hopefully be review problems for you, hopefully ones that you've seen before. What we have now is f of x is 2x times 4 minus x raised to the fourth. This involves both the product rule as well as the chain rule. If you notice, we're going to have f and g. The derivative of f is 2. So right now I'm using f prime g plus g prime f, the product rule, times 4 minus x raised to the fourth power, plus I'm now going to write f, which is 2x, times g prime. In order to find the derivative of g, I now set up the chain rule. The outside is u to the fourth. The inside is 4 minus x. Derivative of 4 minus x is negative 1. Derivative of u to the fourth is 4u cubed. We multiply those, we get negative 4 times 4 minus x raised to the third power. So times negative 4 minus x to the third power. Now, what's great about using the product rule with the chain rule, anytime that happens, you always want to factor the result. So let me show you what I mean. If we rewrite this as 2 times 4 minus x raised to the fourth power minus 8x times 4 minus x cubed, Notice that these have a common factor. The factor that they share in common is 2, and 4 minus x raised to the third power. When I take that out of here, you're left with 4 minus x. When you take that out of here, you're left with negative 2 or negative 4x. And so you can see the factored result. 2 times 4 minus x cubed times 4 minus 5x. Now that would be one way of writing it. You can't distribute the 2 through here because this is currently being cubed. But what you can do is you can distribute the 2 through there. So while this is fine to write, you could also write it as 10 minus 5x times 4 minus x cubed. So please make sure that if you use the product rule in conjunction with the chain rule, that you factor the result in that way. So you can tell that the derivatives definitely can get more challenging than what we've looked at so far. This derivative here, I'm going to rewrite it as sine of 3x, that quantity, squared. That's what it means to square your sine value. And so this is actually the chain rule twice. Watch how I set this up. We have this thing being squared. So you start with the outside and you work your way back in. We have this thing being squared. What's being squared? Sine of 3x. What's the derivative of u squared? It is 2u. What's the derivative of sine of 3x? That requires the chain rule again. We have sine of u, and we have 3x. The derivative of sine of u is cosine of u. The derivative of 3x is 3. Multiply those, and we get 3 cosine of 3x. That is this derivative here, 3 cosine of 3x. Multiply these together, and I get 6 sine of 3x times cosine of 3x. That's my derivative, the chain rule twice. We've already taken a good look at these types of problems, kind of on the back side. These will fall very similarly to what we just did. They're good practice for you. If you'd like to go ahead and do them, that would be fine. What I'm going to do is I'm going to find these derivatives by using more than one rule. In letter A, I do use the chain rule, but first I start with the product rule. As you can see, we have two functions that are being multiplied together, f and g. So f prime g plus g prime f. So the derivative of f is negative 6x times the cosine of 4x. And now I have plus, I'm going to now write f, which is negative 3x squared, times, we need the derivative of cosine of 4x. Going to have to use the chain rule. I have cosine of u, and I have 4x. The derivative of cosine is negative sine of u. Derivative of 4x is 4. Negative 4 sine of 4x. So I multiply negative 4 sine of 4x. You can see here I have negative 6x cosine of 4x. Then I have plus 12x squared sine of 4x. As I said, if you ever use the product rule in conjunction with the chain rule, please make sure that you go ahead and factor out the result. What you can factor out here is a negative 6x. When you do, you're left with cosine of 4x, then a minus 2x sine of 4x. That is my derivative. Letter B is rather involved. By looking at it, maybe you can see that it involves both the chain rule as well as the quotient rule. Now, you might be tempted to set up the quotient rule first, but don't do that. The fact is it's 2 minus x over 2x plus 3 raised to the 1/2 power. So you can see if you work on from outside in, or your last operation in, your last operation is to take it to the 1/2 power, you set up the chain rule to start, which is u to the 1/2. And then the inside is 2 minus x over 2x plus 3. The derivative of u to the 1/2 is 1 over 2 roots of u. The derivative of 2 minus x over 2x plus 3, that requires the use of the quotient rule. F prime g minus g prime f all over g squared. The derivative of f is -1 times the 2x plus 3 minus the derivative of g is 2 times 2 minus x. That's all over the bottom squared, or 2x plus 3 quantity squared. As I deal with the top, I have -2x minus 3 minus 4 plus 2x over 2x plus 3 quantity squared. My 2x's are gone, and so you have your derivative -7 over 2x plus 3 quantity squared. Now, this sometimes frustrates people when you get to this spot, because you do end up with a complex fraction. Don't give up. Just give yourself some extra space and be patient. We have 1 over 2, erase 2 over 1, roots of 2 minus x over 2x plus 3. Okay, so when you plug that 2 minus x over 2x plus 3 back in, you can see the complex fraction that results. You're multiplying that by -7 over parentheses 2x plus 3 quantity squared. What I would like to do is I would like to deal with this complex fraction first before I deal with anything else. And so I have 1 over, I'm going to write this as 2 times 2 minus x to the 1/2 over 2x plus 3 to the 1/2 times then that -7 over 2x plus 3 quantity squared. So if we multiply by the reciprocal, notice that you get 2x plus 3 to the 1/2 over 2 times 2 minus x to the 1/2 times -7 over 2x plus 3 quantity squared. Now, the only thing that simplifies here, but first of all, the complex fraction is gone. But if you look, we have common bases. And so we will subtract the exponents. The derivative is -7 over 2 times 2 minus x raised to the 3/2 power. Difficult derivative there. Whoop, sorry, forgot about the times 2 minus x. Sorry, folks. Try that again. So -7 over 2 times 2 minus x to the 1/2 times 2x plus 3 to the 3/2 when you take that 2 minus 1/2. So ugly derivative, difficult problem, but that requires the use of the quotient rule in that situation. Letter C. This is another tough one. You can see it's set up as the use of the quotient rule right away. Quotient rule is f prime g minus g prime f all over g squared. So the derivative of the top, I'll have to use the chain rule. U to the 4th 3x minus 5. 4u cubed and 3. We multiply and we get 12 times 3x minus 5 cubed times the bottom, which is 2 minus x to the 6th. Minus, now we take the derivative of the bottom. I have u to the 6th. I have 2 minus x. 6u to the 5th and negative 1. We multiply those, we get negative 6, so it'll be a plus 6 times 2 minus x raised to the 5th power. And then we multiply that by f. Multiplied by f, you get 2 minus x, whoops, sorry, 3x minus 5 raised to the 4th power. All divided by 2 minus x raised to the 6th. 12th. We square the bottom. Okay. Now, let's look for common factors here. You can see you have 3 terms. You have 1 term in the denominator. You have 1 term here, and you have 1 term here. So as we glance at those terms, we see that they do have a common factor, 2 minus x. All have at least 2 minus x to the 5th. So if I take 5 out here, they're all gone. And 5 out here, I'll be left with 1 left. And 5 out here, I'll be left with 7. So that would be 12 times 3x minus 5 cubed times 2 minus x. Plus 6 times 3x minus 5 to the 4th over 2 minus x to the 7th. So we got rid of our 2 minus x factors, but now look that we can take a common factor out of the front. That's going to help simplify a few things. We take out a 6 and a 3x minus 5 cubed. If we take out a 6 times 3x minus 5 cubed, you're left with 2 times 2 minus x plus 6 times 3x minus 5. All over 2 minus x raised to the 7th power. Finally, combine like terms. We will have 6 times that 3x minus 5 raised to the 3rd power times, look at what we have here. 2 times 2 is 4, and 6 times negative 5 is negative 30. So that would result in a negative 26. And then 2 times negative x is negative 2x, and this would be 18x or 16x. Or you could write 16x minus 26. All over 2 minus x raised to the 7th power. If you wanted to, you could factor out another additional 2 out of that if you wanted to. Yeah. Did I really just do that? Yeah, did you catch that? Sorry, folks, I'm off my game today. So this 6 right here, we actually factored that out here, don't we? So we didn't need to distribute that 6 through at all. There was no 6 there. Thought that was getting a little wonky. What do you have instead? 2 and negative x makes negative 2x. And then 3x, so I'll just have an x. And then 2 times 2 is 4. And we have the negative 5. So 4 and negative 5 make negative 1. Yeah, that's better. Sorry about that. I hope you're hanging in there. This is a difficult lesson. We're about 20 minutes in. We're going to have a few minutes left yet. Last difficult derivative. The rest of the problems are much easier. I read this as negative 8 times sine of 4x minus 2 raised to the 4th power. So notice as we set it up, you're used to looking on the inside right away. When you have multiple rules, a lot of times it's easiest to set up the outside. Negative 8 u to the 4th. The inside is sine of 4x minus 2. Derivative of negative 8u to the 4th is negative 32u cubed. The derivative of sine of 4x minus 2, I set up another chain rule. Sine of u and 4x minus 2. The derivative of sine of u is cosine of u. The derivative of 4x minus 2 is 4. So I get 4 cosine of 4x minus 2. When you multiply these together and substitute the sign back in, get negative 128 sine cubed of 4x minus 2 times a cosine of 4x minus 2. And that's it. So the derivatives that involve the quotient rule and the product rule are usually a little bit more involved. Let's look at this example. It says let w of x equal u of v of x and find w prime of 3 given the following table values. This is telling us that w is a composition function. Therefore, w prime of x is equal to the derivative of the outside, so u prime of v of x, times the derivative of the inside, v prime of x. Well, we're finding it at 3. So that's where I'm looking right now. V prime of 3 is negative 3 times u prime of, now we need v of 3, and v of 3 is 5. So it becomes u prime of 5 times negative 3. So now I have to look at 5, and u prime of 5 is negative 4. We'll do one of the graphical representations. It says u of x is equal to f of g of x. Find u prime of 1. We're going to use u prime of 1 in this example. U prime of x is going to be equal to, you see we have composition here. So f prime of g of x times the derivative of the inside, g prime of x. Well, we're doing u prime of 1. So first I'm going to start with g prime of 1. You can see g right here. I'm looking at the derivative at 1, so right there. So what's the slope at that spot? It appears to have a slope of 3 times f prime of, now I need g of 3. G of 3, if you, I'm sorry, you plug in 1, so the value 1. So g of 1 has a height of 2. So now in order to complete this, I have to find f prime of 2. So now we look at the f graph. And at 2, what is the derivative? It looks like negative 2. So negative 2 times 3 is negative 6. And that's the result. Last example would be, and again, find an equation for a line tangent to the curve at the given point. So when we started this unit on chain rules, you can understand that find the derivative of 2x minus 3 to the 5th, you would have to multiply that out 5 times. We don't have to do that anymore. In order to find the equation for a line, you just need slope and a point on the line. Your point given is 1, negative 1. To find the slope, just find the derivative. Now I'm going to challenge you in this situation to not set up the table, but rather to look at the derivative of the inside. It is 2. And the derivative of the outside, 5u to the 4th. So maybe you're at a point where you don't need to set up the chain or the boxes every single time. You can simply look at this. Now, when we want to know the slope, we take the x value and we drop it in. And so we get 10 times 2 times 1 is 2, minus 3 is negative 1 to the fourth power. Negative 1 to the fourth is 1 times 10 is 10. And so we have y plus 1 is equal to 10 times x minus 1. Y plus 1 is equal to 10x minus 10. Y is 10x minus 11. 10x minus 11. And there you have it, folks. More difficult chain rule problems. So we tried to start easy the other day. Those are the more challenging ones. Good job. Way to hang in there. We'll see.